before we go to the two-way ANOVA test, let me introduce you to non-parametric alternatives of the one-way ANOVA test. As a non-parametric alternative of between group one-way ANOVA, you can use Kruskal-Wallis test. And for the within group one-way ANOVA test, then Friedman test is a non-parametric alternative. Okay, so the two-way ANOVA. When do we need this two-way ANOVA test? In order to examine any change among mean scores by analyzing the variances caused by an interaction effect as well as sole effect of two variables. Let's consider this example. So here we have the performance of two group of students. One group belongs to class A and the other group belongs to class B. And each class has male students and female students. So in order to identify one performance, you need two informations. One is what class a student belongs to, and second question is whether the student is a boy or a girl, right? So you need at least two independent informations, and the dependent variable is then the performance. So in this case, you have two independent variables and you have one dependent variable. And each of the two independent variables here, by chance, has each of them has two levels. And from the chart, you can predict that if you add the female performances of class A and class B, then the average score of the entire female students will be identical to the entire average score of male students. So if we have investigated the effect of the gender difference on performance, then perhaps we don't see any statistical difference because the mean difference is exactly 0. Likewise, if we average this student's performance of class A, and if we average the student's performance of class B, then those two average scores will be identical. So in that case, also the effect of class division will not be statistically significant. Actually, the mean difference between class A and class B is 0. So consequently, the t-value might have been resulted as 0, right? However, because we know that actually the class A and class B consists of both male and female students. And here this chart shows us that the female students in class A performs better than the male students in class A. However, in class B, male students performed better than the female students. So if there is a combination like which class a student belongs to and which sex a student has, the result or the performance is influenced or has an effect, right? So here we don't expect any of the main effect from neither of the two independent variables, but we can expect an interaction effect. Actually, my recommendation for the two-way ANOVAs or three-way ANOVAs is that when you have a particular expect for an interaction effect. Okay, actually the same data set, and now I have a distinction between male scores and female scores, and here the female student scores are shaded in pink. So I have reformulated the research question like, can we expect different performance of male and female students every year? Previously, we discovered that from the between group one-way ANOVA, the effect of the year difference was not statistically significant. Here, I have divided the people into also two different genders. So one score belongs to, or one score is dependent on two independent variables. The first one is year, what year it belongs to, and second independent variable is the gender difference. And the year had 3 levels and the sex has 2 levels and one dependent variable. So from the two-way ANOVA, you have two types of effect. The first one is main effect. This is the simple effect of one independent variable. Therefore, a two-way ANOVA test examines two main effects and one interaction effect. And the interaction effect is the joint effect of two independent variables. With the additional information about the gender difference, I have inserted a new variable here. So now we have two independent variables and we have one dependent variable. So with these data, let's perform the between group two-way ANOVA test. General linear model and the univariate. Univariate means one dependent variable. For dependent variable, a grade, and for two independent variable, year and sex. And for option, we can additionally or easily get descriptive statistics, so why not? Okay. So we have 60 people, and the 60 people are divided in this way when we divided them according to the year, but the 60 people can be divided also in this way when we divided them according to their gender difference. So let's see here. Every year, we see that the average score of female students was always higher than the male students. Right. And let's check with the statistical difference. Okay. This is a table you should look into. So the one of the main effects here is the effect of year, and the effect doesn't result any statistical significance, and the gender, yes, when we set the alpha level at 0.05, then it's slightly below the 0.05. So we can find the effect of the sex on the student's performance. However, we don't find any interaction effect on the exam scores. Yeah, that's bigger than our alpha level. So although we have applied the two-way ANOVA test to identify the two main effects and one interaction effect, what we have found here is that the gender is influencing on students' performance, so the exam score, but neither the year nor the interaction effect statistically significant. That's what we found here. In addition, this table presents you the partial eta squared values. This implies the power of the effect. Let me continue to the effect size. As we have learned in t-test, the effect size provides an indication of the magnitude of the effect. So based on the effect size, we have a kind of a hint or evidence that the difference have occurred by chance or has a really powerful implication. So differently from the way we calculated the effect size for the t-test, between group one-way ANOVA test uses eta squared value, and this is calculated through this procedure. We have sum of squares of between groups as part of the result of the ANOVA test, and that is divided through the total sum of squares. And for the within group one-way ANOVA test or two-way ANOVA or three and furthermore, the partial eta squared value is required. And as you remember, we just saw the partial eta squared value generated in SPSS table. So once we have the data, then you can consult this table, and as far as I remember, the partial eta squared value for the main effect of the gender difference in our two-way ANOVA test was 0.07. So the effect size is slightly above the medium size. So we can conclude that the gender difference has an effect on students' exam scores, and the effect size is is medium.